Zach is just in time. So, first thing. And again, if you guys aren't following me along with my calculator, for time purposes, I'm just going to be saying out loud, but I will show my calculator. I will post everything on my TV here for like the following problem. Okay. So, first thing, I notice this is angle side side, right? Ambiguous case. Couple things. That means I could have 0, 1, or 2 triangles. And also, I'm going to want to create my ratio with my sides up top because I'm going to be solving for an angle. So again, I see I have a ratio over here. So first thing I want to do, though, is draw my triangle. And I'm just going to say this is case number 1. Because when you have an ambiguous case, when you have that side-side angle, you have no triangle, which we just did, 1 triangle, which would only be case 1, or 2 triangles, which is case 2, which I'm going to do. Okay? But we don't know what that other triangle is. So right now, let's just solve 1 triangle. So here's 38 degrees. No, that's 38 degrees. A is 16, B is 17. Okay, so that's what we're given. So the first thing I realize is I should probably find A, right? That makes sense? So we'll do sine of B over 17 equals sine of A over 16. Sine of B is 38 degrees. Does everybody understand why I chose that ratio to do first? Yes? Yeah, because that's what we're given. You have to use it. I mean, to use the law of sines, you have to have an angle and its opposing side, right? And we're solving for sine, so we're solving for an angle, so I want the angles to be in the numerator. So I want to write the ratio like this rather than that other ratio. Okay? Now I'm just going to multiply by 16 on both sides. And I could say the sine of A is equal to 16 times the sine of 38 all over 17. Now, you could type it in separately, or you could type it in all together. Let's go and figure this out. So I'm going to do sine inverse. I'm going to type it in all together. 16 times the sine of 38. You just got to be careful with your parentheses. Divided by 17. And I get A is approximately 35.412, rounding to the nearest hundredth. Right? But now, here's where students are going to make mistakes. 2 parts. First part, students use the wrong formula or plug in the wrong answers. Okay? That's usually one of the main important things is they use the wrong formula and plug things in. Number 2, they evaluate incorrectly. They don't use their parentheses correctly. So again, guys, if you want to just do order of operations in yourself, do them. 16 times sine of 38. Take that answer. Divide it by 17. Then take the inverse. You can type them all on your calculator, but guess what? That's where people make mistakes. So I would recommend just doing it step by step if you want to. Then the third type where people make mistakes is I'm asking for my answers to be rounded. That is correct. But we don't use rounded answers in other computations. I need to figure out what C is. So to find C, all I need to do is take 180 minus B minus A, and that gives me C. Correct? But I don't want to use my rounded answer. I got to use the full answer. So your 2 options are you could either use the whole answer that's provided in your calculator, which is 35.41593, or you could store it in your calculator, hit store, and save this as alpha A, which again, I'll show back on my computer here in a second. Then what I would type in is angle C is equal to 180 degrees minus B minus A. But instead of typing in all of what A is, I'm just going to use the stored A. So I do 180 degrees minus B, which is 38 degrees, minus 38 minus alpha A. And I get C as approximately 106.5884067. But guys, again, I want to round that. Okay? However, I still need to use this in my calculation. I still got to use this in my calculation, right? Because I got to find out what the side length C is. I don't want to use this angle. Because if I use this angle, I could get that. I'm using a rounded answer. We don't use rounded answers. We need to use the whole answer. So it's either you retype that whole number in, or you get that answer and you just hit store alpha C and store that answer as C. Store alpha C. Again, I'll show it up there. So now, if I want to find my last angle C, I'm going to type in, so now I'm going to flip the ratios. So I'm going to do 17 over the sine of 38 equals C over the sine of my stored C. Does everybody see, though, why I'm using the ratios flipped? Do you guys see this? Because I want to, whatever I'm solving for, I want to be in the numerator. Yes?
I don't understand how you got the C. Like, I typed that in my calculator, but I didn't get that.
Did you store A?
Yeah.
Let me see your calculator. You didn't store A. You stored, no, you stored, no, you did the sine inverse you stored here. Sine inverse alpha A. There you go. So you stored this. You have to take the sine inverse of it. So what I did,
The 35, I got that.
yeah, but after you take the inverse of it.
Oh,
You had to take the inverse of A. And now that's your answer. So now I'm going to store that for you. There you go. Now A is stored. You had the decimal, which you had sine of A as stored. You needed to take the inverse of that. OK? Yes? Because this is stored C. If you wanted to, you could write in what C is. 106.58840067. That's just a lot to type in the calculator, isn't it? So what I do is I store that answer in my calculator, which, again, I will show you. So therefore, you guys can remind it. But it just makes life a lot easier. So now, because you guys can see this problem, we're not even done with solving the first one. We still have another case that we need to check, right? So when I do this now, I can solve for C equals 17 times the sine of C all over sine of 38. So in my calculator, I'll do 17 times the sine of alpha C divided by the sine of 38. And I get little c is 4633519, which rounded OK? Now, yes? Just remember, this bracket C is stored in my calculator. That bracket C is this. OK? Maybe that makes a little bit more sense. Bracket C is that stored answer in my calculator. OK? Instead of typing it all out, I'm just using that C. OK? Now, we need to check for our other case. We have one triangle, but this is really important. We need to check for our other case. So I'm going to redo. I'm going to say, all right, well, that was case number 1. Let's do case number 2. On case number 2, the triangle could look a little bit differently, but I'll just draw the same triangle. Josh. So, Dane, yeah, not what you should be doing right now. Not at all. No. So if you guys go and take a look at this triangle, we figured out in the first case, A, we found A to be 35.4. Was that really the answer? 1, 1, 2. Oh, 1, 2. I wrote that But that's what we found the answer to be, right? Now, what we want to do is see, is there another a? Is there another a2? So what we're going to do to figure that out, is there another case, I'm going to do 180 degrees minus a. So all you're doing is 180 degrees minus that first angle that you found. And you get 144.5884067. Guys, is it possible for this to also be my A? Could I have 144 here, 0.589? Right, so if you guys look at, in this case, what you guys can see is if they are subtracting out, we only have one case in this example, right? So therefore, because this would add up to more than 180, right? Which I thought this problem, unless I wrote it down, b equals, oh, I wrote down the wrong, wait, I did 20, right? b equals 38. Crap, I wrote down the wrong answer. No wonder. I didn't do number 20, no wonder. I did number 19. You guys didn't say anything. But anyways, you guys can see that this only has one case, right? Nobody said something. I said I was doing number